All right, today we're diving into the colossal world of hydropower engineering. And we're going to do it by looking at Nepal, a country that's literally been shaped by the power of the Himalayas. This is a story all about raw energy, some really tough challenges, and the incredible engineering it takes to tame mighty rivers. So let's get into it. So that's the big question, right? How does a nation take the raw, immense power of its rivers and turn it into electricity for millions of people? And believe me, it's about way more than just concrete and steel. It's this amazing journey that starts with just a tiny flicker of electricity more than 100 years ago, then balloons into understanding this incredible natural potential, and finally requires a whole national vision to make it all happen.
You know, every massive engineering project has to start somewhere, right? And for Nepal's hydropower story, that somewhere was way back in 1911. Now, the scale was, well, pretty modest, but the vision, that was anything but.
Yeah, this timeline tells a really fascinating story. It's kind of full of stops and starts. After that first plant in 1911, progress was just a slow trickle for more than 50 years. I mean, think about that. Decades went by with not much happening. But then, wow, something changed. In just the 10 years between 1965 and 1975, the country's hydropower capacity just exploded. We're talking a 20-fold increase. That first little spark finally caught fire and turned into a real, full-blown ambition.
So, just how small was that initial spark? Well, that very first plant, Farping Hydro, it only generated about 500 kilowatts. To put that in perspective for you, a single modern wind turbine can turn out 10 times that much power. But you know, from this tiny little seed, a huge national vision was about to grow.
And yeah, calling that vision powerful is a total understatement. Okay, let's switch gears. We're going to go from that little 500 kilowatt project to the absolute sea of energy locked away in Nepal's rivers. The numbers we're about to look at are just staggering.
Okay, check this out. This chart really puts things into perspective. See that first bar? That's the gross potential, a mind-blowing 83,000 megawatts. Now, what does that mean? That's the absolute 100% theoretical limit. It's like a physicist's dream, capturing the energy from every single drop of water falling through the Himalayas. But, as we all know, the real world has other plans. So, how do you get from that massive, theoretical number down to what's actually possible? This is where the rubber meets the road, you know? It's the exact point where engineering slams right into reality. And that brings us to our next number, technical potential. At 44,000 megawatts, it's still a huge amount of power, but look at that. It's a massive drop from 83,000. So what gives? Well, here's the thing. Building in the Himalayas is one of the toughest engineering jobs on the planet. This number accounts for all the harsh realities. We're talking unstable ground, super steep canyons, and spots so remote you could spend years just building a road to get your equipment there. So yeah, this is reality's first and biggest haircut. So really, it all boils down to two key questions for any big projects like this. First, the engineers have to figure out the technical side. Can we physically actually build a dam here? But then, right on their heels, the economists show up with an even tougher question. Okay, you can build it, but should you? Is it gonna make any money? And that second question? Well, it's all about the bottom line. For a project to get the green light, it has to pass two big financial tests. First, its internal rate of return, which is basically just a fancy way of saying its profitability, has to be better than just sticking the money in a bank. Makes sense, right? Second, the benefit to cost ratio has to be greater than 1. In other words, you have to get more value out than the money you put in. It's this final financial filter that whittles that number down to our most realistic figure, 42,000 megawatts. Okay, so let's take a step back. You've got this history, right? A super slow start. And you have this incredible potential, even after reality has taken its bite. So how do you actually unlock all that power? Well, you need a plan, a national blueprint. And for Nepal, that blueprint was the Hydropower Development Policy. Now, this date is a big deal, October 15th, 2001. That's when the government of Nepal officially approved the Hydropower Development Policy. This was a real turning point, creating a modern, cohesive game plan to manage one of the country's most important natural resources. And this policy laid out 5 pretty ambitious goals. It was about so much more than just making cheap electricity. The plan was to make sure the power was reliable, to use it to fuel economic growth, to get electricity out to rural villages, and, this is a huge one, to develop hydropower as something they could actually export. This was a blueprint for energy independence and for future wealth.
So, you might be wondering, how does a big high-level policy like this actually affect an engineer on a project site? Well, it sets very specific rules they absolutely have to follow. Take this one, for example, environmental release. This rule says that a dam has to let a certain amount of water flow through it at all times. Why? To keep the river's ecosystem downstream alive and well. And it's not vague either. It gives a hard number, 10% of the river's lowest monthly flow. It's a perfect example of how a broad policy gets translated into a very real, concrete number that an engineer has to design for. So where does all this leave us? We've looked at the history, we've seen the absolutely staggering potential and how reality shapes it, and we've walked through the strategic plan for the future. It brings us right back to our main question. With all this in place, what happens next? What are the actual designs, the specific structures, and the technologies you need to really harness the power of the Himalayas and forge a nation's future? We're going to get into all of that in our next chapter.